Climate change throughout Earth history is caused by large basaltic lava flows in subaerial rift zones, causing rapid global warming, while explosive eruptions in volcanic arcs form aerosols that cause slow, incremental cooling over millennia. The footprints of climate change in Earth's record are quite distinctive. Data from deep ocean sedimentary cores show that climate has been changing in irregular cycles varying in length from 40,000 to 230,000 years over the past 5.3 million years. If we expand the last glacial cycle shaded yellow, the same data plotted in green shows slow incremental cooling from 120,000 to 20,000 years before present, followed by the same amount of warming in less than 10,000 years. Ocean temperatures change very slowly because oceans have massive heat content. The black line shows air temperatures measured in ice cores below summit Greenland, with sample time resolutions measured in years to decades. Note very sudden warming of air temperatures by 10 to 16 degrees Celsius within years, followed by slow incremental cooling of air temperatures over millennia. Note that this average sawtooth cycling of air temperatures lasts about 4,000 years, but that it is highly erratic in onset, intensity, and duration. Climate change is very clearly not cyclic. Throughout Earth history, when we have adequate time resolution, climate appears to change significantly from hot to cold and back to hot again every few thousand years on average. Rapid warming at the end of the last ice age was contemporaneous with major basaltic volcanism in Iceland that builds vertically up through the ice, forming flat-topped table mountains known as tuya, as shown in this picture. 13 of these tuya have been dated, and 12 of these dates are during the Bowling warming or the Preboreal warming. The greatest warming shown in green was contemporaneous with the greatest volcanic sulfate recorded in Greenland ice, shown in red. During the Holocene, the greatest warming occurred when basaltic lavas covered areas larger than 700 square kilometers, shown in ellipses in this figure. The eruption of Barðabunga in central Iceland in 2014 only covered 85 square kilometers, but caused rapid warming of 0.3 degrees Celsius from 2014 to 2016, making 2016 the hottest year on record. The largest known basaltic lava flows covered areas up to 11 million square kilometers and were contemporaneous with the greatest known warming, mass extinctions, and ocean acidity. The larger the area covered, the greater the warming and other effects. The Paleocene-Eocene thermal maximum occurred as Greenland and Norway began rifting apart, forming the North Atlantic Ocean. Ages of flood basalts are directly related to ages of mass extinctions that typically occur at the ends of geologic time periods. These flood basalts punctuate the geologic timescale. These are the times when there were sudden major changes in climate, sedimentation, and fossils. Large explosive volcanic eruptions, on the other hand, form sulfuric acid aerosols in the lower stratosphere that grow large enough to reflect and scatter sunlight, causing global cooling of about 1/2 degrees Celsius for 2 to 4 years. The explosive eruption of Mount Pinatubo in 1991 was the largest volcanic eruption since 1912. Its aerosol circled Earth within 21 days, as shown here, spread poleward within months, and lasted 3 years. Such worldwide short-term cooling decreases ocean temperatures for as long as a century, as shown here by the modeling of ocean temperatures following the 1883 eruption of Krakatoa. Modeling of sea level change shows how several major explosive volcanic eruptions per century, continuing for millennia, can cool the ocean incrementally down into ice age conditions. Cooling accumulates incrementally over centuries and millennia. So what causes global warming? There are only three ways that radiation is observed to warm air. First, by conduction, as air comes in contact with Earth's sun-warmed surface and is convected upward, similar to hot air convecting above a frying pan. This is what warms the troposphere. Second, by dissociation in the stratosphere, where solar ultraviolet C radiation dissociates primarily oxygen and solar ultraviolet B radiation dissociates primarily ozone. When you dissociate a gas molecule, you break the bond so that the molecular pieces fly apart at high velocity. The stronger the bond, the higher the velocity. The temperature of the gas is directly proportional to velocity squared. Dissociation, therefore, converts bond energy directly and efficiently into increasing air temperature. Third, by ionization in the thermosphere, where far ultraviolet, extreme ultraviolet, and X-ray radiation ionize molecules of nitric oxide, nitrogen, and oxygen. Ionization converts electron bond energy directly and efficiently into increasing air temperature at an altitude where the air is extremely low density. There is no known physical way that greenhouse gases absorbing low-energy terrestrial infrared radiation can cause global warming. Terrestrial infrared radiation simply does not have enough energy to dissociate anything. Greenhouse warming theory does not recognize the reality that flux of heat is observed to be proportional to the difference in temperature. The black line shows warming observed as a function of time when shining a light on a small piece of black metal. The red line shows warming calculated by multiplying a constant times the final temperature minus the current temperature. Heat flowing per second, therefore, is proportional to the difference in temperature. Greenhouse warming theory is built on the assumption that heat is simply the amount of thermal energy passing through a surface each second. But this mathematical definition of heat never considers what heat is physically or how heat flows physically. Temperature, thermal energy, and heat all result from oscillation of all the bonds that hold matter together. They are intensive physical properties that are not dependent on the size or the mass of the system, and therefore are not additive. They cannot be added together in any physically meaningful way. But greenhouse warming theory is built on the assumption that heat is additive. The more heat absorbed, the hotter a body becomes. It is physically meaningless to add kinetic energies of oscillation together because they and their frequencies of oscillation all coexist simultaneously in distributions at the submicroscopic level. Greenhouse warming theory is rapidly becoming the most expensive mistake ever made in the history of science. We are in the midst of a major revolution in physics and in climate change. Given the investment most people have for or against greenhouse warming theory at this moment, it is going to take many years for most people to understand that greenhouse warming theory is not only mistaken, it is not even physically possible. Currently, leading scientists refuse to even consider the possibility that there could be any problem with greenhouse warming theory. But the science is remarkably clear in hindsight. I bring this up in this talk to emphasize the reality that global warming is caused by something different from changes in emissions of greenhouse gases. Humans manufacturing CFC gases did cause 0.6 degrees Celsius warming from 1970 to 1998. CFCs are broken down in the lower stratosphere by ultraviolet radiation to release atoms of chlorine. One atom of chlorine can destroy 100,000 molecules of ozone. Less ozone absorbs less solar ultraviolet B radiation, cooling the ozone layer and warming Earth. The green line shows the increase in production of CFCs. The black line shows the observed increase in ozone depletion. The red bars show the increase in average global temperature. Ozone depletion is caused both by manufactured CFCs and by chlorine and bromine gases emitted during volcanic eruptions. The black line shows total column ozone measured above Arosa, Switzerland since 1927. The green line shows production of CFCs increasing downward. The purple line shows temperature in the ozone layer. The red names are volcanic eruptions. The red circle shows major ozone depletion following the eruption of Mount Pinatubo. Warming of up to 3.5 degrees Celsius was observed in northern Europe and Canada during the first winter, but then the aerosols became dominant, causing net global cooling. Major explosive eruptions form aerosols that enhance ozone depletion, but ultimately cause net global cooling. The black circle shows major ozone depletion following two much smaller eruptions that did not form significant aerosols. Major effusive eruptions do not form aerosols, but convect chlorine into the ozone layer above the 1200 degrees Celsius lava surface. In summary, volcanoes have ruled climate change throughout Earth history. The greater the rate of major explosive volcanic eruptions per century, the more rapidly Earth is cooled down into Ice Age conditions. The larger the area covered by basaltic lava flows, the greater are the contemporaneous warming, mass extinctions, and ocean acidity. The balance of explosive volcanic eruptions above subduction zones and effusive lava flows in subaerial rift zones is determined by plate tectonics. Extensive detail is provided in a book, web pages, papers, and videos, all referenced at whyclimatechanges.com. Understanding climate throughout Earth history truly does get down to understanding volcanism and tectonics along rifts and volcanic arcs. Thank you very much.